Hello everyone, welcome you all to this session and here we are going to discuss the AIET 7 NEET solutions for chemistry. Okay, so let's start with the first. Yeah, question number 51 says that in which case is the number of molecules of water maximum? So we are asked to find out the more number of molecules of water containing option. Okay. So starting from option A, so A says that it is 18 ml of water. So 18 ml means, so this is the volume given. And we know that density is equal to mass by volume, right? And from this, the mass is equal to density into volume. And we all know that the density of water is 1, right? And the volume given is 18 ml. So the answer is coming out to be 80. So the mass of water is 18 grams. Okay, so 18 ml of water contains 18 gram of water. Okay, so to find out the number of molecules of water, the formula is mole into the Avogadro number. So mole is nothing but mass by molar mass, right? Mass by molar mass into Avogadro number. So the mass of water is 18 gram and the molar mass of water is also 18 gram into Avogadro number. So it is coming out to be 1. So the answer is 6.022 into Avogadro number is 10 power 23, right? So this many number of molecules of water is present in 18 ml of water. Got it? Then coming to option B, we have 10 power minus 3 mole of water. So to find out the number of molecules of water, the given mole is 10 power minus 3. Use the same relation into Avogadro number, that is 6.022 into 10 to the power 23. So we are getting 6.022 into 10 to the power 20. So 10 to the power 20 molecules we are having. And in option C, if you see, 0.00224 liter of water vapors at 1 atmospheric pressure and 273 Kelvin. Okay. So to find out the moles of water from this, this is molecules. Okay, don't get confused. To find out the moles of water, the given formula is volume 0.00 by the molar volume. So 22.4 is the molar volume at 1 atmospheric pressure and 273 Kelvin at ST. Okay. So the answer will be coming out to be -4. So from this we can get the molecules. The molecules of water is equal to mole into Avogadro number. Mole is 10 power minus 4 and Avogadro number is 6.022 into 10 to the power 23. So here we will get 10 to the power 23 minus 10 to the power minus 4. It will be 10 to the power 19. So 10 to the power 19 molecules we are getting. And in option D, if you see, we have 0.18 gram of water. So the number of molecules of water is equal to mole into Avogadro number. So mole is mass by molar mass. Given mass is 0.18 by molar mass of water is 18 into Avogadro number. Okay. So here we will get 10 power minus 2 into Avogadro number 0.22 into 10 to the power 23. So we are getting 0.22 into 10 to the power 21. So from the given 4 options, if you see, the more number of water molecule is present in option A, right? Because it is 10 to the power 23. The remaining things are lesser than that. So option A is the correct answer. Okay. So this we are using this particular relation. That's it. And mole is equal to mass by molar mass. So using these two formulas, we can get the answer from this question. Okay. So coming to the next question, the oxidation number of oxygen in Na2O2 is. So let me draw the structure. Okay, we can draw the structure of Na2O2 like this. And the sodium is electropositive, so it gains -1. Oxygen, it will lose its electron, so +1, and oxygen will gain the electron -1. And with respect to this bond, it is 0 because both the atoms are same. And coming to this bond, sodium is again electropositive in nature, oxygen is electronegative, so it gains the electron and sodium loses its electron. So here if you see, each oxygen is gaining -1 charge. So the oxidation number of oxygen in Na2O2 is -1. Option D is the correct answer. Okay, such an easy question. So then moving on to the next question. 16 gram of an ideal gas with SOX formula occupies 5.6 liter at standard temperature and pressure condition. The value of X is. So now to solve this, let me start with this. At standard temperature and pressure, the number of moles can be calculated using mass by molar mass, which is equal to the given volume divided by 22.4. Okay. So the mass is given as 16 gram and the molar mass we don't know, that we have to find out, and the given volume is 5.6 liter divided by 22.4. And if we solve, we will get molecular mass is equal to 64. Okay. And we know that the molecular mass of sulfur dioxide is 64, right? Molecular mass of sulfur dioxide is 64. So the X value is coming out to be 2. Okay. So the atomic mass of sulfur is 32 and for each oxygen it is 16. We have 2 oxygen. So if we add everything, we will get 64. So only if we substitute X value as 2, we are getting this. So the correct answer is option B. X is 2. Okay. Then question number 55 says that 1 mole of P4 molecule contains. So in P4 molecule, if you see, we have 4 atoms of phosphorus. How many atoms we have? We have 4 atoms of phosphorus, right? So 1 mole of P4 contains 1 mole of P4 contains Avogadro number into the number of atoms, that is 4. Okay. So which is equal to 24.088 into 10 to the power 23 atoms. Got it? So 1 mole contains this many number of atoms. So just we have to multiply the given number of atoms present in that molecule with the Avogadro number. We will arrive at the answer. Okay, so option D is the correct answer for this. Okay. Then coming to the next question. The number of mole of ammonia in 4.25 gram of ammonia is. So the mass of ammonia is given. We have to find out the number of moles. So the number of moles is equal to the given mass divided by molar mass, right? So given mass is 4.25 gram and the molar mass of ammonia. Ammonia is NH3, right? So for nitrogen, the atomic mass is 14 and for hydrogen it is 1. We have 3 hydrogen. So it is 3 and the molar mass is 17. So 4.25 divided by 17 will give 0.25 mole. Answer is 0.25 mole, in which option B is the correct answer for this question. Okay. Then coming to question number 57. For the complete combustion of 4 liter ethane, how much oxygen is required? So we all know the general formula for the complete combustion of an alkane, right? CnH2n plus 2 plus 3n plus 1 by 2 moles of oxygen gives n moles of carbon dioxide and n plus 1 moles of water. So this is the general formula. And we have ethane. So the formula for ethane is C2H6. So here the n value is 2. So 3n plus 1 by 2 moles of oxygen means it will require 7 by 2 moles of oxygen gives n moles, that is 2 moles of carbon dioxide, and n plus 1, that is 3 moles of water will come. Okay. And here if you see the 1 liter of ethane is requiring, this is sum by 2 is nothing but 3.5, right? It requires 3.5 liter of oxygen. Okay, now for 4 liter of ethane, for 4 liter of ethane, how much oxygen is required? So just we have to cross multiply this and get the answer. So x into 1 will be equal to 4 into 3.5 and this will give 14 liter. So 14 liter of oxygen is required for the complete combustion of 4 liter of ethane. Okay, so option A is the correct answer for this. Clear? The general formula for complete combustion is CnH2n plus 2 plus 3n plus 1 by 2 moles of oxygen will give n moles of carbon dioxide plus n plus 1 moles of water. So using this formula, we can get the correct formula, balanced chemical equation for the complete combustion of any alkane. Okay, good. Now moving on to question number 59. For the reaction 2P plus Q giving R, 8 moles of P and 5 mole of Q will produce. So the given equation is 2P plus Q is giving R. Okay, so let me divide this equation by 2. So if I divide this equation by 2, I will get P plus half Q will give half R. Okay. Now here 8 moles of P. So 8 moles of P, 8 moles of P is giving half into 8 moles of R. Okay, because for 1 mole it is half mole of R, no? Then for 8 mole it is 8 by 2 moles of R, which is nothing but 4 mole of R. 4 mole of R. So 8 mole of P will give 4 moles of R. So option C is the correct answer for this. Okay. Then coming to question number 60. If 30 ml of hydrogen and 20 ml of oxygen react to form water, what is left at the end of the reaction? So let me write the equation first. H2 reacts with half mole of O2 to produce 1 mole of H2. Okay. And here if you see, number of moles of hydrogen is 1 and oxygen is half and water is. And here 30 ml of hydrogen is reacting with 20 ml of oxygen to produce 30 ml of water. So this is the thing, right? And here if you see, now 20 ml of oxygen is there. Okay, 20 ml of oxygen is there. And here we have to divide this by 2. That is from 20, 20 is for 1 mole. 20 minus 15. That will give 5, right? For 1 mole, it is 30. And for half mole of oxygen, only 15 would have been reacted with this. Okay. So now at the end, if you see, 30 ml of water will be there in the reaction mixture because that is a product, and 5 ml of oxygen will be there, and the remaining 10 ml of hydrogen will be there. Okay. Clear? So the option 5 ml of oxygen, yeah, it is given in option D. It is given in option D. So option D is the correct answer. Okay. Then moving on to the next question. The amount of salt required to prepare 10 decimeter cube of decimolar solutions. So what is decimolar? Decimolar solution is nothing but 0.1 molar solution. Okay, and we all know that molarity is equal to molarity is equal to number of moles of solute divided by volume of solution in liter. Okay. Now here the molarity it is 0.1. So 0.1 is equal to number of moles of solute divided by volume of solution. That is 10. Okay. That is 10. So from this N is equal to 1 mole. So the number of mole for this particular system is 1. Okay. We all know that volume is given as 10 decimeter cube. Okay. 1 decimeter cube is equal to 1 liter. So means volume is equal to 10 liter. So that's what we have substituted here. Okay. So the number of mole is coming out to be 1 mole. So option 3 is the correct answer for this. Okay. Then coming to question number 62. 11.1 gram calcium chloride is used to prepare a 500 ml solution. Then molarity of Cl minus in solution will be. So mass is given, volume is given. The molar mass of calcium chloride will be equal to 111 gram. Okay. For calcium it is 40 and for chlorine it is 35.5 and we have two chlorine. So 70 point something plus 40 will get 111 gram. This is the molar mass of calcium chloride. And the volume is given as 500 ml. If I want to convert this to liter, I will get 0.5 liter. Okay. So the number of moles, I have to find out the molarity of Cl minus A. To find out the molarity, we need to find out the number of moles of the solute first. So the number of moles of the solute is equal to mass by molar mass. So the given mass is 11.1 and the molar mass is 111, which is coming out to be 0.1 mole. So this is the number of, and the calcium chloride will get dissociated into calcium 2 plus 2Cl minus. And here if you see 0.1 mole of calcium chloride is giving 0.1 mole of calcium 2 plus ion and 2 into 0.1, that is 0.2 moles of Cl minus ion. Now if we substitute this in the molarity formula, which gives number of moles divided by volume in liter, the number of moles of Cl minus ion is 0.2 divided by the volume of solution in liter is 0.5. So this will give 2 by 5 and it is equal to 0.4 molar. So the molarity is 0.4 molar. Option A is the correct answer for this question. Okay. So coming to the next question, we have to calculate the frequency of light having wavelength 500 nanometer. Wavelength is given, we are asked to find out the frequency. And we know that nu is equal to C by lambda, right? Where C is the speed of light. So which is equal to 3 into 10 to the power 8 meter per second. And the lambda wavelength is 500 nanometer. Nanometer means it is 10 to the power minus 9. So it is equal to 0.6 into 10 to the power 15. 0.6 into 10 to the power 15. So it is equal to 6 into 10 to the power 14 per second. Okay, 1 per second is equal to 1 hertz. So the answer is option A. Answer is option A. Okay. Then moving on to the question number 67. Which of the two ions from the list given below that have the geometry that is explained by the same hybridization of orbitons? So 5 molecules, ions are given. We have to find out the thing which are having same geometry and hybridization. Now, coming to NO2 minus. So NO2 minus, the nitrogen's hybridization is sp2. And coming to NO3 minus, again it is sp2. It is sp2. Okay. It is sp2. This sp2. So NO2 means it is N double bond O, and the electron has been gained. So already in the number of valence electron for nitrogen is 5. So we have 2 sigma bond and 1 lone pair. So we all know that steric number formula, right? Steric number is equal to number of sigma bond plus number of lone pair. So we have 2 sigma bond and 1 lone pair. The answer is 3. If its steric number is 3, then the hybridization is sp2. Same way as for NO3. NO3 means we have 6 bonds like this. Okay. So where we have 3 sigma bond and no lone pair. So again, the steric number will be equal to 3. So the hybridization is sp2. Then coming to NH2 minus, NH2 minus, the hybridization will be sp3 for it because NH2 minus. So 5 valence electron plus 1. So totally 6. So we have 2 sigma bond and 2 lone pair. So steric number will be 4. If it is 4, 4 orbitals are mixing. So it is sp3. Okay. Then coming to NH4 plus ammonium ion, the hybridization for ammonium ion is sp3. It is NH4 plus. So there are 4 sigma bonds. So steric number is 4, so sp3. And coming to SCN minus, so the hybridization is sp. So it is SC triple bond N minus. Okay. So we have 2 sigma bond and 2 pi bond and no lone pair. So it will be sp. It is sp. Steric number is 2, so sp. So the species having same hybridization is NO2 and NO3 minus. That is option A. And the geometry for sp2 hybridized system is trigonal planar. Okay, both the species you can see they are trigonal planar in geometry. Okay, so this is how we have to calculate. Then coming to question number 69, 2 moles of helium gas undergo reversible cyclic process as shown in the figure. Assuming the gas to be ideal, what is the work for the process C2T? So just observe the graph given and we have to find out the work done. So the work done can be calculated using minus nRT into a logarithmic function of initial pressure by final pressure, because pressure is given here now, 1 atmosphere and 2 atmospheric pressure. So we have to use this formula. So if we use this, it is minus number of moles is 2 moles. So it is 2 and R into the temperature. Temperature is 400. For C2D, the temperature is 400 into the logarithmic function of initial pressure is 1. C2D. So from C2D, initial for C is 2 and final is 1. So we are getting like this. So the work done will be equal to minus 800 R into Ln logarithmic function of 2. Okay. So option A will be the correct answer for this. Then A will be the correct answer for this. Okay. Then moving on to the next question. 1 mole of NH3 gas at 27 degrees Celsius is expanded in reversible adiabatic condition to make volume 8 times and the final temperature and work done respectively are gamma is given as 1.33. We have to find out the final temperature T2 and the work done. To find out that, so T2 can be calculated using a formula that is T1 into V1 by V2 to the power gamma minus 1. Okay. So initial temperature is 27 degrees Celsius. If I convert this into Kelvin, I will get 300 Kelvin. And initial volume is V and final volume is 8 times that of initial volume. So it is 8V. So to the power gamma is 1.33 minus 1. Okay. So here V gets cancelled and we will have 300 divided by 8 power 1 by 3. That is cube root of 8. Okay. So cube root of 8 is 2. So 300 by 2 will give 150 Kelvin. So this is the final temperature. 150 Kelvin is the final temperature. So option A or option B should be the correct answer. Now coming to the work done. So in the question it is given that the process is adiabatic. So if the process is adiabatic, then the heat exchange between the system and surrounding is 0, right? Q is equal to 0. Then From first law of thermodynamics, delta U is equal to Q plus W. Q is going to 0. So if I calculate delta U, I can get the work done. So we know that delta U is equal to NCV delta T. Okay, NCV delta T. And here the number of mole is equal to 1, and the CV for this is R divided by gamma minus 1 into the delta T. Delta T is 150 minus 300. 150 minus 300. So we will get 1 into our value is 2 calories. So in terms of calorie, it is 2, and gamma is 1.33 minus 1 will give 0.33, and here we will get minus 150, which is coming out to be minus 900 calories. Okay, so we are getting this negative sign because work is done on the system. So that minus sign denotes the work is done on the system, otherwise 900 calories is the work. So option A is the correct answer for this question. Okay. So coming to question number 74, for which reaction is Kp equal to Kc? So we have three cases, right? We know that Kp is equal to Kc into Rp power delta Ng. If delta Ng is equal to 0, then Rt power 0 becomes 1. So the whole term goes to 1. So in this case, Kp will be equal to Kc. Okay. So now we have to find out the number of change in the number of, and change in the number of moles can be calculated using number of moles of gaseous product minus number of moles of gaseous reactant. So number of moles of gaseous product for the first option, if you see, it is 2 plus 1. Okay. For option A, it is 2 plus 1, 3 minus 2. So the answer is 1. So this cannot be the answer. And coming to option B, number of mole for product is 2, and for the reactant is 4. The 2 minus 4 is minus 2. It is also not the answer. And coming to option C, we have 2 moles of HCl and 1 plus 1, that is 2. So 2 minus 2 is 0. So here only delta Ng is coming out to be 0. So that is the correct answer. And coming to option D, so the number of moles of product is 2 and the reactant is 3. So here it is minus 1. So it cannot be the answer. So in option C only we are getting 0 as the value for delta Ng. So that is the correct answer for this. Okay. Then coming to question number 75. The reaction A plus B giving C plus D is studied in a 1 liter vessel at 250 degrees Celsius. The initial concentration of A was 3N and that of B was N. When equilibrium was attained, equilibrium concentration of C was found to the equal to the equilibrium concentration of B. What is the concentration of C at equilibrium? So let me write the given equation first. So A plus B is in equilibrium with C plus D. So the initial concentration of the system is, initially A was 3N and B was N. Okay, C and D would have not been formed. Now the equilibrium concentration. At equilibrium, X moles have been reacted to produce X moles of C and D. So the remaining will be 3N minus X for A and N minus X is for B. At equilibrium, concentration of C should be equal to concentration of B, right? Because both are having same moles. So concentration of C is X and concentration of B is N minus X. So N is equal to 2X and X is equal to N by 2. X is equal to N by 2. So concentration of C and D, they are equal. They are equal. Both are X and X, right? So X is N by 2 and the concentration of D is also equal to N by 2. Okay. So option A is the correct answer for this. Okay. Then coming to question number 76. 4 moles of A are mixed with 4 moles of B. When 2 moles of C are formed at equilibrium, according to the reaction, the equilibrium constant is. So, the reaction says that A plus B is giving C plus D. So, 4 moles each of A and B are reacting. Initially, there won't be any formation of product. And at equilibrium, 2 moles of C and 2 moles of D are being produced. So, here the remaining will be 4 minus 2 for A and the same for B. So, at last, 2 moles of A, 2 moles of B will be there, and 2 moles of C and 2 moles of D will be there. Now, to find out the Kc, what is Kc? It is equilibrium constant. It is nothing but the product of product concentration divided by the product of reactants concentration. So, C and D are the product. So, 2 into 2 divided by A and B are the reactants. So, its concentration is also same. So, the value is 1. So, the equilibrium constant Kc for this particular system is equal to 1. So, option B is the correct answer for this. Okay. Then coming to question number 77. In the reaction 2P plus Q giving 3R plus S, 2 moles of each of P and Q taken initially in 1 liter flask at equilibrium, which is, so the reaction says that 2P is reacting with Q and at equilibrium 3R and S is being produced. Okay, so initially 2 moles of each is there, Q, and after some time P, some minus 2x moles would have been reacted, and here x moles would have been reacted since the number of moles is 2 and 1 here, and here, and the at equilibrium if we see, the remaining concentration will be 2 minus 2x, and here it is 2 minus x. So 3x of R would have been produced and x moles of S would have been produced. So here if you see, 2 minus 2x is small, right? 2 minus 2x is small. So the concentration of Q is greater than the concentration of P. Concentration of Q is only higher than the concentration of P. So option A will be the correct answer for this question. Okay. Then coming to question number 80. The solubility of A2X3 is y mole decimeter per minus 3 and its solubility product is. So A2X3 is the salt, and if it gets dissociated, we will get A into x power 3 plus 2A3 plus and 3x 2 minus. So this is the dissociation, right? So 2s and here 3s. This is the concentration. And coming to the solubility product KSP, we have to multiply these two. So 2s power 2 into 3s power 3, right? So it is 4 into s square into 27 into s cube. 27 into s power 3. So 4 into 27 is 108 into s power 3. And here the solubility is given as y mole per decimeter cube. So instead of it is power 5. Okay, it is power 5. So instead of s, we can substitute y. 108 y power 5 is the solubility product KSP for the given system. Okay, so option D will be the correct answer for this question. Clear? Then coming to question number 84. The total number of nodal planes present in the atomic orbitals with the principal quantum number n is equal to 3. Now for n is equal to 3, L can have values from 0 to n minus 1, right? So means 0, 1 and 2. And 0 denotes the s orbital and 1 denotes the p orbital. It is not 3, it is 2. 0, 1 and 2. 0, 1 and 2. So 2 denotes the d orbital. So s orbital, if we take, we have only one s orbital. P orbital, px, py and pz. And coming to d orbital, we have dxy, dyz, dzx, dx square minus y square and dz square. So s orbital doesn't have nodal plane, so it is 0. P orbital have one nodal plane, and for each p orbital we have one nodal plane, so 1 plus 1 plus 1. And if you coming to d orbital, so the first 4 d orbital will have two nodal planes. Nodal plane means where the probability of finding the electron is 0 is called as a node. Okay. So here we have 3 because it is a double dumbbell shape for d orbitals, right? So we will have two nodal plane for each. For the first 4, we will have two nodal plane. And for d is a square orbital, we don't have nodal plane. So it is equal to 0. Now if you add everything, here we have 3 and here we have 8. So 8 plus 3 is equal to 11. So the total number of nodal plane is 11. So option A is the correct answer. Okay. And coming to question number 85. A stationary helium plus ions emit a photon corresponding to the first line of the Lyman series. The photon thus emitted strikes a hydrogen atom in the ground state. Find the velocity of the photoelectron ejected out of the hydrogen atom. The value of RH is 2.18 into 10 to the power minus 18. So we have to find out the velocity. So how to find out the H alpha of the Lyman series? Lyman series, it is equal to RH into Z square into 1 by N1 square minus 1 by N2 square. So this is the formula. And the Rydberg constant value is 109678 into Z. Z is the atomic number, and for helium it is 2. So 2 square divided by 1 by initial status orbit is 1. So 1 square, and final is 2. So 2 square. Okay. So the lambda is coming out to be 3.039 into 10 power minus 6 centimeter. So lambda will be equal to 3.039 into 10 to the power minus 8 meter. So this is the lambda value. And next we have to find out the energy. So E is equal to hc by lambda. So what is h? It is Planck's constant. 6.626 into 10 to the power minus 34. And c is the velocity of light, which is 3 into 10 to the power 8 meter per second, divided by lambda is 3.039 into 10 to the power minus 8. So this will give 6.541 into 10 to the power minus 18 joule, which will be equal to 40.88 electron volt. So this is the energy value. Okay. 1 electron volt is equal to 10 to the power 1.6 into 10 to the power minus 19 joule. So using this, we can get the answer in terms of electron volt. So this is the energy. Okay. Now, the total energy will be equal to energy of the hydrogen plus the kinetic energy, right? So energy for the system is 40.88 electron volt, and the energy of hydrogen, the first orbit for the first orbit is 13.6 plus kinetic energy. So if we solve this, the kinetic energy will come out to be 4 into 4.365 into 10 to the power minus 18 joule. Okay. And we know that kinetic energy is equal to half mv square, which is equal to 4.365 into 10 to the power minus 18 joule. And from this, half mass of the system is 9.1. Mass is 9.1 into 10 to the power minus 31 into v square is equal to 4.365 into 10 to the power minus 18 joule. So from this, v is equal to 3.097 into 10 to the power minus 18 joule. Okay. So, sorry, it is 3 point, it is not 10 power minus 18, so it is velocity, right? So the answer will come out to be 10 power 6 meter per second. Okay. So the answer is option A. Okay. That's a big question, but we have to find out the velocity from kinetic energy. So we are getting the kinetic energy and using the energy. And firstly, we are finding out the wavelength. Okay. So find out the wavelength, find out the energy, then substitute to get the kinetic energy, and from that get the velocity. Got it? Then moving on to the next question, the ionic radii of the three ions, N3 minus, O2 minus, F minus are respectively. So we know that atomic number is inversely proportional to ionic radii. Atomic number is inversely proportional to ionic radii. Atomic number for nitrogen is 7, and for oxygen is 8, and for fluorine it is 9. Means N3 minus will be greater than O2 minus, then F minus. So here the given values, if you see, 1.71 is the highest, then 1.40, then 1.36. So option C is the correct answer for this question. Okay. Then coming to question number 94, which write the order of Ka1 values of following acids. So in the given three acids, if you see in first molecule, we have one COOH and one NH2. NH2 is an electron donating and COOH is an electron withdrawing. And in the second compound, we have two COOH in the same, in the cis form. Okay. And in the third compound, two COOH are in the trans position. If two are in the cis position, so the withdrawal of electron will be more. Okay. So the acidity will be more. So Ka value is also more. Then coming to compound 3, two acids are a trans. So that will come next. And here NH2 is an electron donating group, right? So it will donate the electron and it will decrease the acidity. So that will have the least value of Ka. Okay. So option A will be the correct answer for this. Coming to the last question. The correct structure of 2-ethyl 3-methyl hexa 1,4 diene is. So the root word is hexa. Okay, in 1 and 4 position we have uh, so we have 6 carbon and 1, 2, 3, 4, 5 and 6. So in 1 and 4 we have a double bond. In 2 we have ethyl and in 3 we have methyl. So the structure is given in option C. So that is the correct answer. Okay. So thank you so much for listening the session. I hope the session is very useful for all of you. Meet you all in the next session. Thank you.